All right, welcome. Today we're cracking the code on the core data concepts you need for the Azure DP-900 exam. We're going to move fast and cover the entire data lifecycle, from the moment it's created to how we keep it safe. Let's dive right in.
So, picture this. You're staring down this classic problem. Thousands of transactions a second. It feels overwhelming, right? Well, the answer isn't just picking one magic product. It's about understanding the process, the entire journey your data is about to take, right from the very start. And that journey always begins with the first, and I mean most critical choice. You have to define the workload. You've got to ask yourself, what job does this data actually need to do? Is it for running the business day to day, or is it for looking back and analyzing how the business is doing over time?
And this brings us to a really fundamental split in how we see data. On one side, you've got OLTP, online transaction processing. Just think of this as the live heartbeat of your application. Every single sale, every click, every inventory update, it's all about speed, frequency, and lots of writing. But on the other side, you have OLAP, online analytical processing. This is for asking those big picture questions, like how did our sales this quarter stack up against last year's? It's all about reading massive amounts of data to spot the trends.
The next piece of this puzzle is all about timing. Is your data showing up in big, scheduled drops, or is it a constant, never-ending river? You've got batch processing, which is kind of like getting your mail once a day. You process a big block of data on a set schedule, like updating the entire product catalog overnight. But then you have streaming, and that's like a live news feed. Data gets processed the very instant it's born. Think of a wind turbine firing off thousands of sensor readings every single second. With streaming, low latency isn't just nice to have, it's absolutely critical.
Okay, so you know your workload. Now what? Well, now you need a blueprint for your data. How are you going to organize it so that it actually makes sense and is efficient to use? This brings us to structure. And the way we actually talk to that structure is with a data manipulation language, or DML. You can think of these as the action words, the verbs for your database. The one you'll see all the time is insert. And it's exactly what it sounds like. It's how you add a new row of data, like a new customer signs up or a new sale is made. It's the right part of the whole read and write equation.
Now, when it comes to those analytical systems we talked about, there's one design that it reigns supreme, the star schema. And it's beautiful because it's so simple. Right in the middle, you have a fact table. This holds all your numbers, the sales totals, the quantities sold, and then radiating out from it like points on a star are your dimension tables. These give all the context, the who, what, when, and where. This simple structure makes asking questions and getting answers incredibly fast.
From there, you can get even more sophisticated with something called a snowflake schema. Think of it as a star schema that's been, evolved. The dimension tables get broken down even further into smaller, more specific tables. This whole process is called normalization, and its main job is to stop you from storing the same piece of info over and over again. Now, there's a trade-off. Your queries might get a little more complex, so it's all about finding that perfect balance between saving space and getting your answers quickly. All right, so we've got our workload figured out, we've got a structure in mind, now we got to find a home for all this data. Where is it actually going to live?
You know, for that superstructured data we just talked about, like in a star schema, a relational database is the go-to, the classic choice. And in the Azure world, that usually means Azure SQL Database. Because it's a platform as a service, or PaaS, Azure handles all the tedious stuff like backups, updates, and the underlying hardware. And the real win here, you get to focus on your data, not on babysitting servers.
But hey, not all data plays by the rules, right? What about stuff that just doesn't fit into neat little rows and columns? That's where non-relational databases shine. And there are 4 main types you should know. Graph databases are perfect for understanding complex connections. Key value stores are all about lightning-fast lookups. Document databases are built for flexible data. And columnar stores, they're optimized for blazing-fast analytical queries on huge datasets.
Let's make this real with a few examples. If you're trying to map out relationships between employees in your company or analyze network traffic, a graph database is the perfect fit. But if you need to store shopping cart data and pull it back in the blink of an eye, a key value store is built for that exact low latency job. See? It's all about picking the right tool for the job.
Okay, our data is stored. Now for the fun part, turning all that raw information into actual valuable insight. This is where we make the data go to work for us.
A really common way to do this is with the ELT process. First, you extract the data from wherever it lives, like a CRM. Next, you load it straight into your powerful destination, say a data warehouse. And here's the really important part. You do the transform step last. All the heavy lifting, the cleaning, the processing happens right there using the power of the destination system itself.
So, once your data is all prepped and ready, the first stop is usually descriptive analysis. This is all about answering one simple but super important question. What happened? It's like looking in the rearview mirror of your business. A perfect example is just reviewing the sales figures from the last quarter.
But, just looking in the rearview mirror is only half the battle. The real magic happens with predictive analysis. This is where we ask, what will happen? We use all that historical data and those trends we found to start forecasting the future, like predicting what sales are going to look like next quarter. This is where data stops being just a record and starts becoming a strategy.
So, you've got all this amazing analysis, but how do you actually make sense of it? How do you share it? You visualize it. And this is where a tool like Power BI is just essential. It lets you build these incredible, dynamic reports and dashboards right in the cloud so you can share those powerful insights with anyone in your organization.
All right, we've reached the final and honestly probably the most crucial stage of all. We've collected our data, we've structured it, we've analyzed it, now we have to protect it.
The great thing about using a PaaS service like Azure SQL Database is that you get a whole bunch of security and management features baked right in, straight out of the box. We're talking fully managed backups, so you don't have to worry. Built-in high availability to make sure your app stays up and running, and even things like advanced threat protection to spot anything suspicious. It's all part of the service.
Hey, remember way back when we talked about OLTP versus OLAP? Well, a read-only replica is the perfect way to solve that puzzle. It's a live copy of your main database that you use just for reporting. This means you can run those huge, heavy analytical queries against the replica, and your main application, the one handling all the live transactions, never even feels a thing. It's the best of both worlds.
And last but not least, you have got to lock down who can get in. Securing access is everything. And the absolute best practice here is to go beyond just passwords and use Azure Active Directory authentication. This lets you enforce modern security standards like multi-factor authentication, making sure that only the right people can get to your most valuable asset, your data.
So, there you have it. From defining the workload all the way to securing the final insights, that's the data lifecycle. Every single step builds on the one before it, turning this stream of raw facts into a powerful, compelling story. And really, the only question left is, now that you know the language, what story is your data waiting to tell you?